Hi everyone, welcome to the class, and in today's class we are coming towards the end of physical world and measurements. Most of the concepts we have covered, right? So when we did physical world, the chapter of physical world, we did not cover measurement of time alone, right? We will look into that very short concept, after which we will move into last class we did error, right? We did what are the types of errors. We also saw the elimination, how do we eliminate errors, right? So in this class, continuation of that, we will do what are the combinations of errors. So that these are the two topics we will be doing today. And on that note, my name is Mohana. I'm a physics educator here at Unacademy. So if you're taking your class 11 and 12 physics here, I'll be teaching. And this is my Telegram group link. You can follow this channel for any updates. At the same time, this is the common ICSE and ISC Board Telegram channel. Alright, you can follow this channel as well. Now, just like how we have special classes on the free classes on the YouTube channel, we also have free classes on the Unacademy app. Okay, so these classes are absolutely free. You can take any of your favorite educators classes, and at the same time you can engage with the educator via pool feature, and you can check out this feature, and as well as you can, since these free classes are also live classes, if you have any doubts you can get them solved then and there as well. And in the description link, the link to the upcoming special classes for class 11 will be there, so you can register for the same. You can just have to click on the link. It will take you to the Unacademy platform. There you can just click on enroll and give your details. Before the class could go live, you will be notified. All right. Now, the upcoming classes on the YouTube channel is, on the Unacademy platform is going to be on 27th. This class will be at 4 p.m. So this class we are going to see basic mathematics for physics. So this is part 2. So we'll be looking into differentiation and calculus in this part, right? And after that, on 29th June at again 4 p.m. There is another free special class. So this is going to be applications of vector. So part of the application of vector, right, we did part 1, we already did. Now this will be part 2 of the series. All right. Okay, so on again, whatever we are seeing in the YouTube classes, in the next few classes we will be doing vectors. Now this would be basically, in this class we will be looking more into the applications of those vectors in our day-to-day life. All right. Now if you're interested in the plus subscription, now there are some benefits. One is you can learn from the comfort of your homes, and you can get unlimited access to all courses. So whenever you're taking a plus subscription with Unacademy, you're not just taking one course, you will be getting physics, chemistry, math and biology. So basically you're getting 4 subjects. Now all the educators on the platform are really good, so you'll be learning from top educators. Now we have an interesting feature, which is basically the doubt clearing session. Now any plus course you take, every 4th session is going to be a doubt clearing session. Okay, so the first 3 days, in case if you have any doubts in any of the previous concepts, right, you can get those doubts cleared. Or otherwise, let's say in the previous classes, one of the classes by chance you couldn't attend them live, right, and you're seeing the class recordings will be available in that case. In case if you're seeing the class recordings, right, then if you still have any further doubts on the 4th session, you can actually, on the doubt clearing session, you can get those doubts cleared. Okay, and in a plus subscription we will cover your entire syllabus. Okay, the entire syllabus is going to be covered. Now there will be more practice tests on the app, right, and also since these classes are live, right, if you need any mentorship or guidance, you can take it from the educators. And at the same time, there is every other week we also have the live test series. Okay, so this is your weekly mock test series. Okay, every other week we will have. So in this test series, what we would do is, right after if you attempt a test, right after that there will be an analysis session. In the analysis session, whatever doubts you have, right, with the questions that you attempted, in case if you made any mistakes, you can get those doubts cleared. Or in case if you want to ask the educator, like, is there an easy way to solve that question, you can get those doubts cleared as well. Okay, tests are like, anytime you learn a new concepts, always try to take a test, so that will actually help you understand how well you had understood the concept. Okay, now we have an upcoming batch coming, the details of which I'll give you shortly. But before that, whenever you take a plus subscription, right, the longer duration you take, the price per month goes down. Okay, see, this is the price for 3 months course. But if you're in class 11, if you're taking a 2 months course, 2 years course, then per month you're paying only 1198 rupees. Okay, this is you're paying for 4 subjects. Okay, that is the month you're paying. But on top of it, if you're using my educator code MTIS10, you will actually get a 10% discount on the same price. Now you'll get the same price for 1078 rupees. Alright, so the longer duration course you take, you will get the price per month goes down. Okay, now the upcoming live batch, this is an ongoing course, right? This course started on 8th June only. In case if you had missed any previous classes, class recordings will be given to you. Okay, and you can actually get and you can actually watch the class recordings and get your any doubts you have, right? You can get those you can watch the class recordings, and then onwards you can start attending the live classes as well. So you're not missing out a lot right now. Even if you're taking now, you will get the class recordings. Okay, so the mode of delivery is going to be in English. So physics I'll be taking, right? We will meet every Tuesday, Thursday, Saturday between 5:15 to 6:15. Similarly, for other subject also, the other educators who would be taking, with the timing of the courses actually given. But if you're in class 11, okay, if you're taking a subscription plan, you can always use my code, right? MTIS10 for a 10% discount. On top of it, if you're taking a class 11 1-year subscription, right, class 12 subscription is absolutely free for you. So you're just paying for 1 year and you're getting a class worth of and you're getting the course worth for 2 years. For example, if you're using the educator code and you're getting a course for somewhere around 1000, right, over here it was shown that the course per month goes down to if you're using the educator code, around 1078 rupees, right? So in this case, what happens is in a month you will have a minimum 10 math classes, 10 physics classes, 10 chemistry classes, and 10 biology classes. So the minimum number of classes is going to be 40, minimum 40 classes per month. Okay, and the price you're paying is somewhere between 1000 to 1200 a month, right? So the price per course actually come down to somewhere around 30 rupees. That's the minimum price you're actually paying for a course. All right, just a moment. So that's around, right? So you're paying less than 30 rupees per class. Okay, that's the lowest price you're getting at. Okay, other than this, you actually have a practice test series and everything else as well. Okay, on that note, I've given you all the introduction about the upcoming live classes and also about the plus courses. Now let's begin the topic, right? So we started this with the topic measurement or measurement of time, right? That is the only thing from physical unit which was actually left out. Now, according to Einstein, right, time is simply what a clock reads. Okay, any phenomenon that repeats itself after equal intervals of time can be used as a standard time. For example, your heartbeat. Okay, it's actually, this is a phenomenon that is getting repeated, but the phenomenon is also happening at equal interval of time, right? Now this is an example of for measurement of time, beating of a heart. If you take a pendulum, right, if you basically take a pendulum, so you know the pendulum swings from one end to another, right? So this is a repeated action which happens for in equal interval of time, right? So oscillation of a pendulum, that is an example of measurement of time. Okay, now at the same time, the rotation of Earth about its own axis, how Earth is rotating on its own axis, that is also could be taken as a example of measurement of time. Okay, now similarly, revolution of Earth around the sun, that also could be taken. Okay, and vibration of a quartz crystal in quartz wristwatch. Okay, this is because of piezoelectric effect. You may not come across this much, right, but it's a very simple concept, right? And the period of vibration of cesium-133 atom. Okay, now this is taken as the most accurate standard of time of all of these, right? Period of vibration of cesium-133 atom is taken as the most accurate standard of time. Why cesium-133 atom? It's to do with its energy level. Energy level concepts you will learn actually in your grade 12. Okay, so when you get to there, you will understand how energy levels are connected to frequency, and we know frequency is frequency and the frequency is nothing but 1 by time period, right? So from there, how we get time period, you will understand more about these energy levels only in your grade 12. Okay. Now, the advantages of, since we are saying that the cesium-123 atom, right, the period of vibration of that is taken as the most accurate standard of time, it becomes important for us to define the advantages of defining seconds in terms of period of radiation of from cesium-133 atom. Okay. Now, the cesium-130, the cesium atomic clock made out of cesium, the cesium atomic clock, right? They have a very high accuracy, 1 parts in 10 to the power of 13 parts. Okay. The accuracy is so high. All right. Now, this can also be easily reproduced in any good laboratories. Okay. And this particular clock, it is not affected by any physical condition like change in temperature or pressure. None of those affects this particular clock. Right, and also it is imperishable. These are the advantages of using a cesium-133 atomic clock. All right, and these are the advantages of defining seconds in terms of cesium-123 atom as well. Okay, next, the measurement of time. Some of the techniques for measuring time intervals over different ranges we would see. All right, one is what is an electrical oscillators. Okay, in India, if you take the power supply, that voltage we are getting is around 220 volts. Right now, the AC the AC that we are getting, the AC we are getting in a house, right? The frequency of that particular AC is 50 hertz. Right, AC you will again learn in your class 12 only. In detail you will be learning. All right, class 10 you would have again come across this as well. Okay, and a motor, if a motor is running synchronously with this particular AC, okay, then this AC can be used to provide a time scale. Okay, a motor running synchronously with this AC can be used to provide a time scale. All right, that is one. Another one is what is electronic oscillations. Again, you will come across it only in your grade 12. Okay, you will learn more about transistors and all of those in your grade 12. Okay, a junction transistor. Now, these can be used to produce oscillations of very high frequency, which can be used to measure small time intervals. Okay. The next one is your quartz clock. This is something you come across in everyday life, right? So a quartz clock, this basically shows piezoelectric effect. So what is piezoelectric effect is, let's say there will be like two slabs, right? Two parallel faces, okay, in these clocks, right? And if you apply any sort of pressure, okay, but the applied pressure to this is going to be a fluctuating pressure, okay. Now, the applied fluctuating pressure across this pair of parallel faces, right? This actually producing an oscillatory EMF. Okay, oscillatory EMF means what is the work done in moving a charge. Let's say this charge is a positive or negative charge. Let's say this is a charge. In moving a charge from one place to another. That is basically your EMF, work done in moving a charge from one place to another, right? So work done per charge gives you your EMF. EMF is nothing but a potential difference. So if your charge is moving from one point to another, then there is current. Okay. Now, because of this, you can actually your oscillating EMF is developed across these parallel plates, right? In case if you apply the oscillating EMF, okay, a changing EMF, then you will get a changing mechanical fluctuation will also be produced, meaning that the fluctuating pressure will be produced. So any mechanical stress is converted into electrical. Okay, one thing you can see is in your lighters, right? As you click the gas lighters that you're seeing, right? The pressure that you apply produces a spark. Is a quartz crystal inside it. All right. Now, so any mechanical pressure or any force that you're applying, mechanical pressure is converted into electrical in this case. Okay. The oscillation produced in this case, right? Whatever the oscillation is produced, that is used to measure the time intervals. All right. Now, other than this, the next is atomic clock. Okay. These clocks are based on the periodic vibration taking place within the atom. Alright, and the first cesium atomic clock was set up in 1964. The next one is actually the decay of elementary particles. See, the life of many elementary particles, when you're talking about elementary particles, any particle that cannot be further subdivided. Electron is an elementary particle. Okay, the lifetime of an elementary particle varies from 10 to the power of minus 16 to 10 to the power of minus 24 seconds. Okay, now if you, by making use of their decaying time, right, if you want to measure very small intervals in the range of 10 to the power of minus 16 to minus 24 seconds, that can be done. Okay. This leads us to the last technique. One is the last is the radioactive decay. Now this decay is used to measure very long time intervals. Okay, for example, in years, you can take years or decades together, centuries together, right? For very long time period when you're taking, then you're taking radioactive decay. Okay, this we do. So to find the radioactive decay, this is given by the ratio how many number of radioactive atoms has undergone decay to that of the number of atoms that are left undecayed. That actually gives you the ratio of these radioactive decay. Alright. Now, in radioactive decay, in case of carbon dating, this carbon dating is used to find the age of the fossils. But if you're using uranium dating, right, then that is used to find the age of the rocks. This is something about, these are the concept about measurements of time. The only concept when we did physical work, we did measurement of length, measurement of mass, measurement of time, we left it, right? So we're doing it in today's class. Now, till now we actually did for measurement of time, right? Let's do one more numerical also. Very simple numerical we'll do. Okay, let's say the average, okay, average life of a man. Let's say average life of an Indian man. Okay, average life of a person. Average life of a person. Let's say he's living around 56 years. For example, 56 years. Okay. Now, we're going to find out, let's say, his heartbeat. Heart beats once, let's say, once in 0.8 seconds. All of the problems that I am doing will be taken from your actually from your reference books. All right, link to all of the reference books are also given below in the slide. All right, so let's say heart beats once in 0.8 seconds. Okay, knowing this, okay, we're going to find the number of times the human heart beats in a lifetime. Number of times the human heart beats in a lifetime. Okay, very simple. Now, because here we are seeing this in seconds, right? Heart beats once in 0.8 seconds, and here we have average lifespan of a person as 56 years, right? Let's convert this 56 years in terms of seconds. Okay, so lifespan, average lifespan, right? What I'm going to do is I'm going to erase all of this and let me just quickly do this. Okay. Okay, average life of a person is 56 years, right? 56 years in times of seconds will be 56 into 365.25, right? So many days in a year. Okay, in 56 years, 1 year has 365.25 days, and 1 day has 24 hours, and 1 hour has 60 seconds, right? 60 minutes, and 1 minute has 60 seconds. So if you do this, the average lifespan of a man, okay, this is the average lifespan of a man. Okay, now what was the period of heartbeat we saw? Period of heartbeat. Period of heartbeat was around 0.8 seconds, right? Now, what will be the total number of heartbeat? Total number of heartbeat in 56 years. Okay, that's going to be the average life of a person, that is 56 years, right? That will be 56 into 365.25 in terms of seconds we are writing, into 60 seconds, right? By the period of heartbeat. What is the period of heartbeat? 0.8 seconds. Average lifespan by the total period of heartbeat, that is 0.8 seconds. Seconds over here gets cancelled, alright? So if you solve this equation, if you have solved it, you can actually give it in the chat box. Alright, you will get around 2.2 2 into 10 to the power of 9 times. 2.2 into 10 to the power of 9 times. This is how much times the heart beats in 56 years. If the period of heartbeat between two heartbeats, right? One period between one heartbeat to another, the period if you're taking is around 0.8 seconds. Okay, right. So with this note, let's actually move on to the next measurement, errors in measurement. All right. So we started this unit with what do you mean by errors, right? Now, whenever you're taking any number of whenever you're taking any measurements, for example, if I want to measure what is the mass of this pen, there are two ways. The measurement is reliability depends on the measuring instrument I'm using to measure the mass of the pen and the skill, how much skilled I am in taking that particular reading. Okay. Now those are the two things any measurement will be subjected to. So if you want to reduce errors, then you have to take whenever you take repeated number of readings. Okay, let's say I measured the mass of this pen once. Okay, or I'm using a screw gauge to find what is the thickness of this pen. Okay, I'll take multiple readings, right? Every time I take a reading, the reading won't be same. Correct? So from there, we can say there is some sort of an imperfection in measurement. And these imperfections can be measured in two ways. One is accuracy, another is precision. Last class, we saw in detail what accuracy is. Accuracy means whatever the close value is. Let's say the close value for the thickness of the pen is around, let's say, 2.1 centimeters. Okay. Now let's say by measurement I'm getting 2.2 centimeters. Now this value is very close to 2.1 centimeters, right? Then we can say, or let's say let's say the value is around 2.132 centimeters. Let's say I'm getting around 2.130 centimeters. Then the value is very close to the true value. Whatever value I measured, it's very close to the true value, right? Then we say my value is actually very accurate. So very accurate means the measurement has less error in it. Next time we talk about precision. Precision depends on what is the resolution or limit to which the quantity is measured, right? For example, if I measure this thickness of the pen using a screw gauge, my least count will be around, I can get up to 2.12, up to 0.01 centimeters I can get. But at the same time, if I use screw gauge to find the thickness, then I'll get up to 3 decimals. That is around let's say 2.1324. Like 3 digits after the decimals I can find. Which means the least count of the instrument, right, talks about resolution, right? Precision is basically depend on the least count of the instrument. If the instrument has a very small least count, for example, least count of screw gauge is 0.001 centimeters, right? Wherein a vernier caliper has just 0.1 centimeters, right? Now if you see, you will get up to 3 decimal points. Here, if I measure the thickness of the pen, I'll get only up to 2 decimal points. So when the least count is smaller, then precision will be greater, because I can get up to 3 decimal points, I can get very accurate value. Alright, so this is about precision and accuracy. Now what is errors in measurement? Whenever you take whatever is a true value, how do you find the true value? You can take any measurement, you can take it as a many number of times you can repeat the experiment, and the average of that you can take it's close to that actual value. Okay. Now whatever is the actual value of the experiment, okay, let's say I find the thickness of the pen and I find the thickness of the pen, okay, the actual thickness of the pen, let's say it is around 2.312 centimeters. Okay, let's say that is the actual thickness of the pen. Now I get around, when I do the measurements, I get the value of 0.130 centimeters. Okay, what is the difference between them? The difference between these two quantities is 0.002 centimeters, right? This is your error. So true value, what was the true value minus what was the measurement value? That gives you the error. So error, okay, in measurement is equal to difference between true value and the measured value of a quantity, right? Now different types of error. We have constant errors, systematic errors, random errors, and least count errors, and gross errors or mistakes. We have done all of these. Okay. Constant errors actually affects each observation by small amount. We have done this in the previous class lectures. You can check that. And systematic errors, these tend to occur in one direction. There are different types of systematic errors. One is if there is an error in the instrument. Okay. Then if there is, when you're taking the reading, if there is any imperfection in the technique, okay, that could actually lead to systematic errors. Next, if the personal error, if a person who's taking the reading is making careless mistakes, that can lead to an error. and error due to any external causes. Let's say using a steel scale to measure some length or something, and because of the change in the external condition, because of change in temperature, the steel ruler is expanding. Then this is errors due to external causes. Okay. Then you have random errors. Now these errors occurs irregularly and and it also occurs randomly. And these errors are seen in both magnitude and direction. These are called as random errors. Okay. Next is least count errors. Okay. This is due to the limitation imposed for the least count of the measuring instrument. Okay. Very simple. Let's say if I want to measure the thickness of the pen, okay, using inch tape, I'll get only up to 2.1, 2.3. Only 0.1 I'll get. Right. So if I measure this, I'll using an inch tape, so around 2.1 I'll get. But if I use a screw gauge, I'll get 2. Let's say 1.5. Let's say I use a vernier caliper, I get 2.136, right, or 156, right. Now errors, these are because of least count. Okay. See, if I use a screw gauge to find the thickness of this pen, I'll get much more accurate value or precise value than using just an inch tape. Right. So these errors, in this case, these errors are due to limitation imposed by the measuring instrument. Okay. The smallest division that you're seeing on the scale of a measuring instrument, we call that as the least count. Okay. Next is gross errors. This occurs due to either carelessness of the person or due to improper adjustment of the apparatus. Okay. Quick overview I've given about all types of errors. Now, how do we eliminate errors? Because there might be error, what we want to do is, every time you take a reading, okay, let's say you are actually trying to take the, let's say you're trying to find what is the period of oscillation of a pendulum. You just don't take one reading, right? You take multiple readings. If you want to find what is the resistance in a circuit, in an electrical circuit, you want to find what is the resistance. Okay, then you take multiple values, right? You just don't take one, you take multiple values and you take the mean of the same. Right. So whenever you have whenever you're doing error, right, whenever you want to eliminate error, okay, what you can do is the arithmetic mean of all measurements can be taken as the true value of the measuring quantity. Okay. For example, the mean of all value, you take this as mean, or they also write it a bar on top. Okay. Let's say you're trying to measure what is the thickness of this particular pen. First reading you take, that will be A1. Second reading you take, that will be A2. Third reading you take that will be AN, up to, let's say you take n number of readings by n. Sum of observation, or sum of how many readings you have done by number of observation. Right. So if you taken 5 values, add all the 5 values, divide by 5. That will give you the mean. Okay. Now from here we also saw what are the different types of errors. One is absolute error, then you have mean absolute error, then you have relative error, then you have percentage error. Okay. Last class we have seen all of this with actually example as well. So this class I'm just going to give the formula because that's going to help us in combination of errors. Okay. Now whenever you're talking about absolute errors, now the magnitude of different values between true value and the measured quantity, okay, and the individual value is called as absolute error. Let's say the mean value of a particular reading is A bar. Okay. Now let's say if I'm finding the thickness of the pen, first time I would have done the measurement, right? Let that be A1. Second time I did the measurement, let that be A2. Okay. The nth time I did the measurement, let that be AN. Now absolute error is given by delta A1. Absolute error is taken for each and every reading. Okay. Now if you take the mean value minus the individual value, that will give you the absolute value. Second reading also, you take what is the mean value, the final true value, minus for the second reading, what is the value you got. Okay. That will give you the absolute error. Similarly, for the nth absolute error also, it is the mean value minus that particular nth reading, what was the value you got. That will give you the absolute error. Okay. Next, for absolute error means you're taking for individual reading. Now, this absolute error when you're taking, sometimes it can be positive, sometimes it can be negative. So what we do, we take an arithmetic mean of all the positive magnitude of the absolute errors. That gives us the final or the mean absolute errors. Okay. So when you're talking about mean absolute error, we take the modulus of individual errors, right? We take the modulus of this error. Why we are taking the modulus? We want only the positive value. Okay. We want the first one. Hello Siddhartha, you want to explain how to measure using with vernier caliper, right? Siddhartha, if you actually, I had done that in the first class, right? A quick overview I've given with the picture. let me check. All right, no. The measurement you would do with the how would I try to include it in the following classes with a picture? Would that help? Sometimes when I'm doing physical unit, I will include a picture and then try to give you the explanation. Okay? When you have to deal with the measurements. Okay, so this is delta A1 plus delta A2, right? And so on up to mean. What is your positive, okay? Mean absolute error by the total number of absolute error. This gives you about the total or the final mean absolute error. Okay. Next is relative error. Relative error is very simple. Okay, you use it as delta A. Okay, relative error. If you take the mean absolute error, okay, if you take the mean absolute error, okay, and you divide it by the actual value, then you get the relative error. Now, if you express this relative error in terms of percentages, then you get percentage error. Okay, if you express this relative error in terms of percentages, right? Whatever this relative error is, if you express it in terms of percentages, then you get the percentage error. Okay. Till this point, we did in the previous class. We also did, okay, we also looked into some numericals also we solved for each of these cases. Okay, so you can check out the previous class recordings. Now, today's class we will focus on what are the combinations of errors. Okay, because whenever you take whenever you do an experiment, right, there will be several measurements. Okay, and the final measurement value you're getting will be, you always depend on different physical relationships, right? If in case you want to measure force, it's just mass into acceleration. It's just not one value, right? There are two physical quantity involved over there, right? Now, similarly, as you keep so the any measurement that you're taking, right, the final result that you're getting has different physical relationships, right, between fundamental quantities. Correct. Now, the errors in the final result will depend on individual measurement as well as the mathematical operation that you're doing, right? So, in case if you're doing F is equal to M into A, right? Simplest equation. Whether did you do the multiplication, right? That is one error that you'll get. Okay. Then measurement wise, did you make any error? That is another other error you will get. Okay. Now, we can follow some rule to evaluate the maximum permissible error in a measurement. Okay, how much maximum error is allowed, right? For that you can actually follow some rule. One is, what is the error when the quantities, when two quantities are getting added? Okay, when two quantities are getting added, you can actually find what is the error. Okay, next is when you're finding difference, okay, in two quantities, you can actually check what is the error. Errors in difference of two quantities. Okay, now what is the product? What is the error when you're multiplying two quantities? That also you can find. You can find errors in division on quotient as well, and errors in the power of the quantity as well. Alright, these are the errors you can find. Okay, first one is, what is the error when in the sum of two quantities? Okay. Right, so if you say, okay, let's take, okay, let's say you're doing two measurements. Okay, you have two values. Let's say the values A and B. Okay, now in this value A and B, you will get some absolute errors. What will be absolute error? Absolute error will be delta A, and this will be delta B. So, whatever the mean value is minus that individual value will give you the absolute error, right? So, you have two absolute errors also. Okay. Now, what will be the measured value of A? Measured value of A. Measured value of A will actually be, okay, A plus or minus delta A, right? It could be A. Let's say I'm finding the thickness of the pen. The thickness of the pen, let's say, let's say the actual thickness of the pen is 2.143. Okay, and let's say you are getting the reading as the first time you did the experiment. Let's say you're getting the reading of you're getting the delta A to be around the mean delta value, right? Yeah, sorry, the value of around 0.003. Okay, so plus or minus 0.003 means this value could be 0.40 or it could be in the range of 2.146. It could be within this range, right? That will be your measured value. All right. So measured value of A, right? It could be within this range from here to here, plus or minus A, right? So this is the measured value of A. Now, what will be the measured value of B? Measured value, okay, of B will be, what is the B value with the absolute error, right? With the absolute error. Now, you have to consider the sum of them. Let's say their sum is Z, that is A plus B. Okay, then the error, what will be the error in delta Z? Okay, error in delta Z, okay, error in the sum will be given by delta Z, right? Now, error in the sum will be what? Error in this particular sum will be, let me do that in the next page. Error in the possible sum will be Z plus delta Z. Z plus delta Z will be what? A plus or minus delta A, right? Plus B plus or minus delta B. Correct? Here I can take the quantity, right? A, actual quantity, A plus B, I can take it outside over here. Then I'll have plus or minus delta A plus delta B. Okay. So from here, I can actually say A plus B value is what? Z, right? Z will be equal to plus or minus delta A plus delta B. So this is equal to Z plus delta Z. From here I can say delta Z, okay, Z gets cancelled, right? If I bring the Z to the other side, Z gets cancelled. Delta Z will be delta A plus delta B. Okay. So from here I can say the maximum possible error when you're adding two quantities, okay, is the sum of the absolute errors of the individual quantity. Okay. The maximum possible errors, right, in two quantities, right, is equal to the sum of the absolute errors in the individual quantities. Okay, let's try to get that with an example. Let's try to understand this with an example now. Okay, now let's say the let's say you're measuring let's say there are two resistors. Okay, let's say these two resistors are connected in series. Okay, this is R1, this is R2. Okay, two resistors, they are connected in series, right? Now the resistance value for the first one, let's say this R1 is basically around 100 plus or minus 3 ohms. Okay, and R2, let this be around 200 plus or minus 4 ohms. They are connected in series. Okay, when two resistors are connected in series, if you want to find what is the equivalent resistor, meaning instead of using two resistors in the circuit, if I just want to use one single resistance, what will be that resistance value? Okay, in case if they are connected in series one next to another, alright, then we add them. When the total resistance R will be R1 plus R2. Okay, what is R1 over here? 100 plus or minus 3, right? Plus what is R2 over here? 200 plus or minus 4. I have just not written the ohms here. Okay, now you can add this first values, right? The individual values, that is 100 plus 200, right? Then plus or minus, and then I can add this value 3 plus 4. Okay, 3 plus 4, right? So here what will I get? Okay, this will be around 300 plus or minus 7 ohms. Okay, this will be the equivalent resistance in case of series measurement, right? This will be the value. So what do we see? The sum of the maximum error, possible error of when you're adding two physical quantity will be sum of the absolute errors. This plus or minus 3 and plus or minus 4 was the absolute error. What was the sum of the absolute error? That becomes the sum of the maximum error. Alright, this is when you're doing combinations of error when you're adding. Similarly, if you're doing the same thing, but in this case you are finding, right, in this case you are actually finding what is the difference, okay, errors in difference in the measurement. All right. So in this case, let's say you are taking, we are going to consider the same thing, right? Let's say you're subtracting two quantities. So the final quantity will be A minus Z will be, final quantity will be A minus B, right? What will be the error in this final quantity? What will be the error? Let's say error is delta Z, okay? In Z the error is going to be plus or minus delta Z, right? Now this will be what? This will be again equal to A plus or minus delta A, okay, minus, right, B plus or minus delta B, right. So let's take this quantity separately, A, then I have minus B, right, then I have plus or minus, then I have delta A, right. If I just take this minus side inside, right, plus or minus delta A, in this case if I take the minus side inside, right, then this will become this quantity over here becomes plus or minus becomes minus or plus delta B. Alright, so from here you can say this is nothing but Z plus or minus delta A minus or plus delta B, right? This is equal to Z plus or minus delta Z. From here I can say delta Z is nothing but, right, delta A, right, delta A, okay, in this case you can say this is delta A and minus delta plus delta B. Because if you want the error to be maximum, we want to see what is the maximum error possible, right? If you want delta Z to be maximum, then the only possible value is you can't have a negative sign in this case of difference. You can only have a positive sign, because here we are trying to see combinations of errors in which what is the maximum possible error. Okay, so the rule over here is the maximum possible error in difference of two quantities is equal to the sum of the absolute error of the individual quantities. So the maximum error, possible error when you're subtracting two quantities is that it will be equal to the sum of the absolute error of the individual quantities. Okay, for example, let's say you are trying to find, let's say there is a particular object, or let's say there is a liquid in a container and the temperature, okay, the initial temperature, okay, or let's say there is a glass of water, okay, its initial temperature, let's say it was around 18 plus or minus 0.5 degrees Celsius. Okay, let's say after some time the final temperature, let's say you're heating it, okay, you're heating this, let's say in a vessel there is some water and you're heating it. This is the initial temperature to begin with. You're heating it, and the final temperature, after some time, the final temperature that you're finding is around 40 plus or minus 0.3 degrees Celsius. Okay, we want to find what was the rise in temperature, right? This is what we want to find. Rise in temperature, okay, this is exactly what we want to find. Now rise in temperature is actually given by what is the final temperature, okay, minus what is my initial temperature. Okay, this is, let me just write initial temperature. Okay, final temperature is what? 40 plus or minus 0.3, right? What was the initial temperature? Minus, we want to find initial temperature is 18 plus or minus 0.5, right? Here we will take 40 minus 18, right? then you have plus or minus when you're doing error analysis, when you're finding what is the maximum error, and when you're subtracting, do not subtract the absolute error part. This is the absolute error. Do not subtract the absolute error. You have to add the absolute error, because when you subtract, the error becomes least, right? But what do we want? We want to find what is the, and it will be a negative value also, right? In this case, it will be a negative value also. Maybe or may not be, but sometimes the error, with the maximum, the idea is here, if I do 0.3 minus 0.5, I get minus 0.5, minus 0.2. What will happen in this case? The error value reduces. What we are trying to find? We are trying to find what is the maximum error this particular experiment can have, right? Then in that case, we have to add the values. So when you're doing subtraction, always remember the absolute error part, you have to add them. Okay. So this will be around 40 minus 18 is 22, plus or minus 0.3 plus 0.8 is 0.8, okay, degrees Celsius. This will be the rise in temperature, meaning whatever the rise in temperature is around, is between 22.8, okay, to degrees Celsius to around 21.2 degrees Celsius. This is the range the temperature is in. Okay, so the error is around 0.8. Okay, when you're doing subtraction, do not forget to add the absolute error part. Alright, okay, now from here, let's see. Now we have seen addition, we have seen subtraction. Combination of errors. Let's see what happens when error is a product of two quantities. Okay, so we're going to take two quantities. Let's say Z is equal to A plus B. Sorry, this is a product, right? Z is equal to A, Z is equal to A into B. You multiply. Okay, here if you see, you can actually do, let's say you're actually trying, okay, you're actually trying to find that that displacement is equal to velocity into time, right? So this will be Z, this will be A, right? This will be B. Okay, so from here, whatever the velocity is, we have to consider the error because of velocity and error because of time as well. Okay, so that will give you the total error in the distance. Okay, so when you're doing this, so error, what will be the error in the sum? Z, right? This error will be what? This error will be Z plus delta Z. In Z, the error is delta Z. Okay, this is equal to A plus or minus delta A, right, into B plus or minus delta B. Okay, so here product, right, A and B, you can take these two quantities, then you have plus or minus, then you have the next set of quantities, right? So what will be the next set of quantities? Here be careful, you're multiplying, right? So the next set of quantities will be A, right? First you took A into B, right? Next will be A into delta B. That will be plus or minus A into delta B. Okay. Next over here you will have B into delta A, right? So plus or minus B into delta A. Finally you will have plus or minus delta A, these two quantities, delta A into delta B. Okay. So what we are going to do, we are going to divide both sides. Okay, we are going to divide both sides by AB. Okay, so I am going to divide this whole side by AB, and I am going to divide this whole side also by AB. Okay, then what will happen here? If you take Z by AB plus, okay, let me just do this in the, probably in the next page, right? There will be more space in that case. Alright, so first I'll have Z by AB plus or minus delta Z by AB. Okay, this is on the left hand side, right? What will be on the right hand side? I will again have AB by AB plus, right, A delta B by AB plus B delta A by AB, right? So sorry, this will be plus or minus, again plus or minus delta A, delta B by AB, right? This is what we have. Here Z is nothing but AB, right? So AB by AB plus, here instead of AB I can write Z because that's what we defined, right? Z is equal to A into B, right? Here Z is equal to A into B, right? That's what we defined. So here AB by B becomes 1. 1 plus, instead of AB I wrote Z, alright? This is equal to, over here AB by AB divided by AB. This will again become 1 plus or minus, right? Next quantity A gets cancelled. You will have delta B by B. Next quantity over here B gets cancelled, plus or minus delta A by A. Next quantity plus or minus, I am just writing delta A by A, right, into delta B by B. Okay. See, whenever you're taking delta A by delta B, okay, for example, what it means is, let's say A value is around the actual value over here, let's say the mean value is around 5.23, okay, and how will you get delta A? Delta A will be, what is the mean value? Let's say the mean value is around 5.24. That will, let's say this is the true value, this is the mean value, okay, mean value minus, what is this A value? 5.23. So the difference between them is around, for example I am taking, is around 0.01, okay. Now if you take over here 0.01 divided by, what is the A value that we took initially, right? Mean A value is 5.23. Let's say this is the value. 0.01 by 5.23 is a very small quantity. It's almost, the numerator term is almost going towards 0. So this whole term will be in 0.00 points, very small quantity, okay. So this delta A by A, these terms you can eliminate, okay, because these values will become very, very small. Right, you can actually eliminate delta A by A and delta B by B. You can eliminate these terms. You can actually, these are small quantities. These are small quantities. Okay, and when you're thinking of product of them, right? When you think of product of them, the product of them actually becomes even smaller. Because they are small quantities, the product of them will become even smaller, right? Let's say 0.01 into 0.02. The answer goes in 0.00, right? It goes up to 10 to the power of minus 3, minus 4 terms, right? So these two, the product of them can be neglected. Why? Because delta A by A and delta B by B is a small quantity, product of them can be neglected, okay? Then you will have 1 plus or minus delta Z by Z equal to 1 plus or minus delta A by A plus or minus delta B by B. Okay, this 1 on both sides gets cancelled, right? So finally you will have delta Z is equal to, delta Z by Z is equal to delta A by A plus delta B by B, right? So from here you can actually say the maximum fractional error in a product of two quantities, right, it's always equal to the sum of the fractional error in the individual quantities. Okay, maximum fractional error you're getting. Okay, in this case, why? What do we learn? Where did we learn as fractional errors? Absolute error by the mean value, right? If you're taking absolute error with the true value, absolute error to the true value that you're getting. If you're taking that, then we get, that is nothing but your relative error, right? Relative error is also called as fractional error. Okay. So when you are taking in product, when you're multiplying two quantities, okay, the error in them, the final error in them will be the sum of their fractional errors. Okay, sum of the fractional errors or the relative errors gives us the final error measurement. Okay, similarly, if you take for division, okay, that here also the same thing only. Here also the final error that you're getting will be sum of the individual fractional errors. Alright, so this is also of the same thing as we did before only, but this time we are dividing the quantity and we get this particular value. Okay, now Alright, let's do one questions because we came till here, no? Let's say the resistance. How is the resistance given by? We know V is equal to IR, right? IR. From there, resistance will be V by I. Right? Resistance will be V by I. Okay? Let's say this V value over here is 100 plus or minus 5 volts. And let's say the current value over here is 10 plus or minus 0.2 amperes. Okay? What will be the percentage error of R? Right, let's find percentage error of R. Okay, percentage error of R. Okay, the total percentage, if you want to find what is the total percentage error of R, right, this will basically be given by delta R by R, okay, into 100, right. Percentage error is relative error into 100 will give you percentage error. This will be equal to what is the percentage error because of the voltages, right? Percentage error because of voltages plus percentage error because of the current. This is what we saw in the previous term. Percentage error because of voltage, percentage error because of current, that will give you what is the total percentage error in case if you say Z is equal to A by B. Okay. So error in division or quotient of two quantities means the maximum fractional error in the quotient of two quantities is the sum of the fractional errors in individual quantities. Okay. So from here, if you are actually writing, right, this delta V by V into 100, right, that would be around, so this will be 100 by 5 into 100. Okay, sorry, this will be 5 by 100, this will be 5 delta V, this value is delta V, this is basically V, okay, this is delta I, this is basically I. So this will be 5 by 100 into 100 percentage, right, plus this value, right, plus what about the current? In this case current will be, in this case, yeah, current will be around, current we are seeing is around 2, right? Okay, so here we are actually seeing if when we are looking at current 0.2, 100% of 0.2 is what? This is your relative error, right? This basically gives you, okay, this basically gives you, this delta V over here gives you what is delta I by I. This 0.2 gives you delta V by I is 0.2%. Okay, so this is the mistake. I mean, it is not a mistake, but delta V by V is nothing but, this is your fractional error, right? Fractional error is given by, in this case, 5 volts is nothing but, in this case, this particular 5 volts that we are looking at, right? This value is nothing but, this 5 volt is nothing but delta V by V. That gives you 5 volts. So this will be 5 into 100%, right? Into 0.2 into 100. Right, so this basically gives you around 5% and this gives you around 2%. So from here you can get around 5% plus 2%, right? From here the total error, resistance error will be around 7%. That's the percentage error of R is around 7%. Alright, with this we are coming towards the end of the class. Once again, the ongoing batch, this is for class 11. Is Brahmastra. So this batch, the focus of this batch is your midterm syllabus coverage. Alright, so the first 5 units will be covered. Okay, so whenever you're taking a plus subscription with Unacademy, you are actually getting, for the price that you're paying, you're getting 4 subjects: physics, chemistry, math and biology. Okay, these are the 4 subjects you're getting. Now in a month, for math you'll get a minimum of 10 classes for each of the subject. So in a month, minimum 40 classes per month, minimum of 40 classes per month. Okay, now other than this there will be practice test available for you, analysis, live practice series will go, analysis of that will happen. Excluding all of this, minimum 40 classes alone. Each class duration is 1 hour. But for physics, we will be meeting every Tuesday, Thursday, Saturday between 5:15 to 6:15 p.m. right? Similarly for math, chemistry and biology also the timing is given. Alright, now since the course started on 8, whatever classes that, in case if you have not still taken the batch, it will be right time to take now. Whatever classes you have missed, class recordings for the same will be given. Okay, then you can watch the class recordings, and in a plus class, every fourth session is a doubt clearing session. Okay, so in the doubt clearing session, any doubts you had on the previous missed class recordings, you can ask. All right, so don't worry, we are here to help you in case you've missed any classes as well. Okay, and here, if you're taking one, if you're in an advantage, if you're in class 11, you're in absolute advantage. You can just pay for 1 year class 11 subscription, and you will be getting class 12 subscription absolutely free. You just have to pay for 1 year class 11, and class 12 subscription is absolutely free for you. Okay, so you can take class 11 subscription, and class 12 subscription is free. To get that, you can use my code MTIS10. Okay, if you're using this code, on top of this, you will get also the whatever plus course you're taking, you will get a 10% discount on the same. Okay, with this note, we are coming towards the end of the class, and also the same goes for class 12 as well. Alright, for class 12, we meet every Monday, Wednesday, Friday between 5:15 to 6:15 p.m. Alright, and there is an ongoing batch. For class 12, we started classes a little bit earlier simply because moving ahead in the year, you will have more time for revision. Alright, now we are introducing the Unacademy community app. Okay, you can follow any of your favorite educators community. The link to my community app will be given in the description box. You can go there. I will have actually shared few questions in MCQ types. You can try attempting them. Okay, questions will be from your first unit only. Then you can also share your feedbacks directly with the educators via poll features as well. Now, in any of the videos, if you are seeing any inappropriate content, alright, you can report the same, and you can claim your prize. And if you have any questions right now, I'm happy to stay back and help you answer the questions. All right, now if you like the class video, please share it among your friends and subscribe to the channel so you will be updated about the upcoming classes, and also click on the bell icon to get notified about the same. All right, and thank you guys for taking the class, and we'll meet again in the upcoming next classes. So do check out the special classes on the Unacademy app as well. Alright, okay guys, thank you.